At the end of last year, the International Energy Agency, or IEA, was tracking approximately 700 plus CCS projects. And if these projects are fully implemented, they would be estimated to capture, store, transport over 2 billion metric tons of CO2. So that's quite a significant number.
Hello and welcome to the Pumps and Systems podcast. Today we're speaking with Frank Ma, president of JFMA Consulting, about carbon capture and storage, or CCS. He's going to tell us all about what role pumps manufacturers can play in the growth of this technology and related decarbonization efforts. So without any further ado, let's get into the episode. All right, so welcome to the Pumps and Systems podcast. We really appreciate you being here. So how are you doing today?
I'm doing very well, Tom. It's great to be here, and thank you for having me back on the podcast.
Yeah, thank you for being here. And yeah, that's true. Having you back. I mean, you actually have a longer history with the podcast than I do.
Yeah, and I actually did a podcast with Drew back in 2022 on hydrogen and carbon capture, and it's a pleasure being back on this podcast.
Glad you came back after all these years. So, okay. Well then, before we get into our main topic, would you mind introducing yourself? So tell us who you are, what you do, anything you would like our listeners and viewers to know.
So briefly about my background, I have over 20 years of experience in industrial technologies with a focus on rotating machinery and flow control. I am currently president of JFMA Consulting, a boutique consulting firm that serves small and medium industrial companies and their private equity investors on flow control strategy and M&A topics. Before that, I held senior leadership positions at John Crane, a leading mechanical seals provider, and I was also previously a management consultant at the Boston Consulting Group. I am a mechanical and aerospace engineer by training.
So today we're going to be talking about carbon capture and storage, or CCS. So we're going to start with the absolute basics. So can you tell us what are the basics of CCS? What is it? What is it for? Tell us all about it.
So Tom, let me briefly start with a macro big picture around the topic of energy transition, which essentially is a transformation of the world's energy systems from a fossil fuels driven energy system to one driven by low carbon technologies and renewables, while importantly, during this transition, keeping costs down and low and meeting growth in energy demand. So this is the classic energy trilemma, and it's a massive and very challenging undertaking. Now, carbon capture and storage, or CCS, has been identified as one of the key decarbonization technologies and is forecasted by many research agencies and the IEA to contribute somewhere between 5 to 10% of total carbon emissions reduction, and particularly in hard to abate sectors such as in natural gas, cement, steel, and other industrial sectors. Fundamentally speaking, CCS revolves around the capture of carbon dioxide, CO2, from a wide range of different applications, and then transporting this CO2 and storing it or sequestering it, typically underground. At the end of last year, the International Energy Agency, or IEA, was tracking approximately 700 plus CCS projects around the globe. And if these projects are fully implemented, they would be estimated to capture, store, transport over 2 billion metric tons of CO2. So that's quite a significant number. Of course, not all of these projects will be approved, and there will be new projects that potentially come into the pipeline as well. So as we think about CCS, it's also important to think about a scenario-based approach in terms of how the market could potentially develop over the next 5, 15, 25 years plus. Generally speaking, there has been quite a bit of momentum in CCS over the past 12 to 18 months. we've seen oil and gas companies like Exxon and Chevron having announced that, CCS is a core pillar of their decarbonization strategy. We're starting to see other sectors outside of oil and gas, such as in power generation and cement, some of their operators there putting money down when it comes to projects in CCS. We're starting to see some of the large CCS storage hubs become operational. A key example of that was Northern Lights in Norway in last year. And it's not just the US taking market leadership in CCUS, which historically it's done, but other countries such as the UK recently announced a $28 billion investment into CCS as well. So we're starting to see other countries also take leadership roles in this space. With that said, broadly, CCS does have challenges. In general, it is very expensive, much more expensive on a dollar per ton captured CO2 abatement standpoint than other technologies such as solar and renewables. A big challenge around limited infrastructure. So once you capture the CO2, you've got to be able to transport it and store it. We don't have that infrastructure at scale today to be able to accomplish that. And there are a lot of questions also around the commercial and technical viability of the CCS. And oftentimes, government support is needed to be able to justify the business case and the return on investment. So there are a lot of challenges to the industry before it could properly scale up that needs to be overcome.
And regarding CCS, so like essentially you're capturing the carbon dioxide and then transporting it and storing it underground is how it works, right?
That is correct. That is the essence of it, to be able to store the carbon emissions underground on a permanent or semi-permanent basis.
Because yeah, cause I did a little research before the podcast, so I could at least know something, and it made me wonder, like, is there a way, like, is it just like permanent storage? Like the idea is we're just going to keep it under the ground forever, or is there like a plan to try to, disperse it or destroy it or remove it somehow, or is that like a problem for the future?
So when it comes to the carbon dioxide, there are in general two broad categories in terms of how you want to manage it. You can store it, sequester it underground, ideally permanently, so the emissions don't seep up into the atmosphere. Or you could utilize that carbon dioxide into production of, say, sustainable aviation fuels. So that is another potential area where companies and organizations are thinking about how do we actually invest in the CO2 utilization, reuse it so that you don't, again, let the emissions going into the atmosphere. For
Mm.
the purpose of, I think, for our discussions today, our focus has been very, very much around the storage element. How do you actually sequester it underground?
All right. So yeah, so this is of course the Pumps and Systems podcast. So I have to ask, what role do pumps play in the CCS ecosystem?
Pumps, particularly centrifugal pumps and systems, are mission critical flow control equipment that we believe plays a critical role in CCS. They could be considered almost the industry workhorse first, and they are and widely will continue to be deployed across different parts of the CCS value chain, not only in direct conveying of the carbon dioxide, but also in the various balance of plant operations at a CCS facility. So examples would be pumps used to circulate amine solvents, or pumps used to transport feed water that goes into the facilities. So again, they play a mission critical role in the whole ecosystem. Secondly, pumps and their associated systems can represent upwards of 10% or more of total facility cost. So, pumps will actually play a critical role on the cost competitiveness of the total site. And that's really important because, one of the points I mentioned earlier is that CCS is actually quite expensive. So to a degree that you could reduce total cost of ownerships and pumps and systems, it actually has a benefit in scaling the overall ecosystem. And of course, pumps play a critical role on the availability, reliability, and safety of the site. Not all pumps used in CCS will be centrifugal. There are different types of technologies of pumps that will be deployed depending on various factors of flow rates, temperatures, pressures. But we believe centrifugal pumps will most likely be one of the largest, if not the largest market for pumps within CCS.
All right. So let's shift to talking about some of the key market outlook findings. So what are some of those findings when it comes to overall growth and geographical trends, end use markets, technology, things like that?
Our assessment, which we conducted at the end of last year, was based on two scenarios roughly aligned with the IEA stated policies and announced pledges scenarios. And in our base case, we believe that the total addressable market, or TAM, for centrifugal pumps could be over $2 billion by 2040, growing at a compound annual rate of about 20% plus. So we believe that actually it has some very attractive elements for industry stakeholders. As a comparator, what does that actually mean in terms of 2 billion? The global pumps market for oil and gas today is estimated at 10 billion. And of course, that market took decades and decades and a much longer horizon to develop over time. So we think that this market for CCS centrifugal pumps could be a very attractive growth opportunity, both in the original equipment as new facilities are built out, and then also the aftermarket, which we anticipate growing quite substantially in the decades to come. From a regional standpoint, we do expect North America to be the largest market with about 50% of the total global TAM. And this is mostly driven by a combination of reasons with established CCS networks, existing installed base of pumps, and more attractive government policies, which would facilitate investment in this area. But some other countries, like in parts of Europe, around the North Sea, the UK, in the Middle East, in Australia, has the potential as well to grow substantially, but it's very much dependent upon the country and regional policies. We've also found that from an end market perspective, oil and gas is expected to be the largest market segment opportunity with about a third of the total TAM. And this is particularly in areas like in natural gas processing, in LNG, and low carbon hydrogen production. Most of the pumps also going into oil and gas are built to stringent API standards and often sold at premium prices, which obviously makes the market more attractive. There are also opportunities in bioenergy, such as ethanol production. And we also believe that there will be opportunities in power generation, particularly as the build out of data centers for AI necessitates the need for natural gas power generation. And you hear, companies like Microsoft have recently announced that they're evaluating gas-fired plants with CCUS to be integrated into their data centers. So that could be a very interesting market opportunity as well. From a pump standpoint, our research indicated that roughly the breakdown of engineered pumps and standard pumps will be about 50-50 by value, but the majority of pumps will be what's considered standard configurations. And we anticipate that as the industry scales, pump equipment and configurations will become more standardized, more modularized, to help reduce the total cost of ownership. So I think that's an important insight from the research. However, we do believe that in certain applications, highly engineered pumps will still be required, such as in supercritical CO2 handling and transport. And then finally, the research indicates that most of the pump technologies today are proven and are available to scale the overall ecosystem. I think that's a very critical point. But if we want to really get to the next frontier in terms of performance, in terms of lower costs, in terms of reliability and safety, there will also need to be specific targeted innovation and R&D, particularly in areas around materials. So those are just a quick snapshot of the key summaries from the report.
So you mentioned earlier that the infrastructure to support CCS doesn't really exist. So what can we do, or what does the future look like in terms of infrastructure for this?
It is very interesting because when we talk about infrastructure, it's referring to again to the transport of capture CO2 to the location of storage. Now, some infrastructure does exist. So the US and Canada actually has over 5,000 miles of CO2 pipelines that already exist. But the purpose of those, the existing infrastructure is to transport CO2 and use it for enhanced oil recovery, basically to extract more oil out of reservoirs, not to actually store the CO2 into underground locations. And so to be able to then for a facility to invest in CO2 capture, they need to have some confidence that infrastructure would be built to transport that CO2 to the location of storage. And so here we have the classic chicken and the egg problem, right? If you're an investor, you don't want to invest in carbon capture unless you know you can transport it and store it. But if you're a pipeline owner, you may find it challenging to build a pipeline without all of the permits and customers to supply the CO2. So there's a degree of uncertainty there. In the US in particular, there's also the challenge of getting permitting approvals for pipelines. It's a big topic in the States. It's a big topic in our federal government. And how do you actually get multiple states, multiple jurisdictions, landowners to come on board to approve the pipeline that you need to build? And we find that the research indicate that that is quite challenging. One of the key pipelines in the U.S. right now is Summit Carbon Solutions pipeline. They're trying to build that pipeline to connect a number of ethanol plants in the Midwest and store it underground in North Dakota. Some of the states have approved it, but the South Dakota government, the state government, has signed a bill recently, just making it very difficult to get the relevant approvals. And if you don't have that, then actually the whole project probably cannot go forward. So infrastructure and lack of infrastructure, there's a lot of challenges with that. Interestingly enough, our research indicates that one of the largest opportunities for pump OEMs and service company is in the infrastructure space. So, if as the market develops, I think, whether or not these projects will go through will dictate whether the opportunity can be realizable for the pump industries.
Yeah, so it sounds like there are a lot of challenges, but how are pump manufacturers responding to meet these challenges, or what should they do or can they do?
So we're observing several key trends in terms of how pump OEMs are responding. First, large pump OEMs, especially those exposed to the energy sector, have announced CCS as a critical pillar of their growth strategy. So if you take Flowserve as an example, they recently declared that CCS is central to the 3D growth strategy and are actively pursuing flagship projects in this space. Other pump OEMs we observe are being slightly more cautious and hedging their bets until how they understand the market could evolve over time. Most pump OEMs are offering proven pump solutions. And this is important because it demonstrates that there is extensive experience and a wide range of products available to meet the industry needs today and to do it in a very safe way. We're also observing that pump OEMs are prioritizing strategic flagship projects, aggressively chasing after these projects to importantly build references and to win installed base. And finally, we're also observing that they're investing in selective technology innovations, not necessarily broad-based innovations, but because of limited certainty in terms of how the market could develop, but targeted strategic innovations in areas such as supercritical CO2 handling, advanced materials, and digital solutions, which are important because pump OEMs could also leverage that into other applications and other industries as well. In addition, I think we're also observing other stakeholders like EPCs actively investing into the CCS space. They're building dedicated CCS engineering teams. They're investing in in-house pump and sometimes compressor capabilities and knowledge, and they're partnering with pump OEMs on specific technologies. And we think that's actually quite important because it contributes to facilitating knowledge sharing and collaboration, which ultimately the aim is to accelerate the development of the overall industry.
All right. So, what do you think, in general, what do you think are the key actions that should be taken to unlock future growth when it comes to CCS?
So there are a set of recommendations that we believe are important for companies to undertake, particularly those wanting to build a leading position in this space. First, develop a scenarios-based CCS strategy. Take into consideration how the market could evolve, how the market could grow, your areas of differentiation, and then ultimately develop a sensible implementation roadmap incorporating how you would execute the strategy based on certain milestones of industry development. And then think through what are the important no regret actions that you could take under all market scenarios. And some of these no regret actions could be, on the commercial side, leverage your existing install base, document your existing pump install base in operational CCS facilities already to understand references, understand performance histories, understand technical capabilities, and where some of the gaps that you may need to invest. And then prioritize existing customers for growth, especially those in investing in CCS already. Importantly, also think through how do you want to start developing and training your workforce so that they better understand CCS applications, they better understand how the pump technologies operate in CCS applications. From a technical standpoint, I think there are some no regret actions there. A lot of pump companies have a broad-based range of products that they're selling into CCS. So defining a set of flagship products that are preferred for specific applications can be a differentiator. It could help you with decreasing your lead time when it comes to product selection, reducing the amount of iterations back and forth between the pump companies and the customers, and ultimately making you potentially a better company to work with. Importantly, as I mentioned earlier, CCS is still very expensive, and pumps play a critical role in the overall cost of CCS deployment. So think through how, what are some value engineering opportunities, cost reduction opportunities, standardization and modularization of your existing solutions to help reduce the overall total cost of ownership for the customers. And then finally, strategically invest in new technologies and capabilities, but focus again on capabilities that you can leverage not only in CCS applications, but it can extend and expand into other industry applications as well. So these are some of the actions that we believe pump companies who want to take a leading position can take to gain competitive advantage in this space.
So before we finish up, do you have anything else to add or any final thoughts you'd like to leave us with?
North America is going to be one of the market leaders, if not the market leaders, in driving CCUS. There's a lot of different reasons for that. So I think companies who are, who want to take a leadership position will have to think about how do you invest in the North America market. We know there's obviously some uncertainties right now from a policy perspective, but the general view is that, the existing policies are attractive. There's a lot of existing infrastructure, and the workforce capability and the talent capability is quite strong. So if you want to be a global leader in CCS, it's important that, you invest in the North America market.
All right, then. Thank you so much for taking the time to talk with us today. We really appreciate it.
Well, thank you. Thank you so much for having me, and I appreciate the time.
Huge thanks to Frank Ma for taking the time to speak with us today about the role pumps play in carbon capture and storage. If you're listening to the podcast and would like the chance to watch it, stop by our YouTube page to see the full video version. That's going to do it for this episode. Thank you so much for watching or listening, and we will see you next time.